In section 1.8 coordinate geometry, we're going to talk about some information that you already know from algebra and geometry and talk about how it relates to the equation of a circle for our unit on conic sections. So to begin with, if you know two ordered pairs on a line, you can find the distance between those two ordered pairs. We'll call those two ordered pairs x1, y1, and x2, y2 by taking the square root of the squares of the differences and then the sum of those two numbers. The midpoint formula is the average of the x-coordinates and the average of the y-coordinates. And then your slope formula, which is a rate of change, tells you how fast one quantity is changing as compared to another. In this case, it's the change in y over the change in x. So in example 1, we want to find out which of these 2 points, P, which is at 1, -2, or Q, which is at 8, 9, is closer to point A, which is at 5, 3. Well, to figure that out, we're going to use the distance formula. Now, one of the things you can do if you want, and if it helps you, you can draw a picture. For this, though, we don't really need to draw a picture. We can just use the distance formula. So let's start off with what's the difference between point P and point A? Well, in order to do that, we're going to take the square root of the difference in the x's. Which order do you subtract in? Do you do 1 minus 5 or 5 minus 1? It really doesn't matter, because what's going to end up happening is after we're done subtracting, we're going to square that quantity, and either way it's going to be positive. So since I wrote P first and A second, how about I do 1 minus 5 squared plus, and in the second parentheses we'll subtract the y's, and I'll do it in the same order. I'll do -2 minus 3 squared. So I get -4 squared plus -5 squared, which is 16 plus 25, and 16 plus 25 is 41. Okay, so now let's try the distance from Q to A. I'm going to set it up the same way. Since I wrote Q first, I'll just write the x value from Q first. So I have 8 minus 5 squared plus 9 minus 3 squared. So I have 3 squared plus 6 squared, which is 9 plus 36, which is the square root of 45. Well, which one's closer? Which value is bigger? Is the square root of 41 bigger? Or not bigger? I mean, we want to know which one's closer, so I guess we want to know which one's the smaller one. So, which one has the least difference? Is it the distance from P to A or the distance from Q to A? Well, the square root of 41 is going to be smaller than the square root of 45. So the distance from P to A must be closer than the distance from Q to A. In example 2, we want to show that the quadrilateral with vertices at P, 1, 2, Q, 4, 4, R, which is at 5, 9, and S, which is at 2, 7, is a parallelogram by proving that its two diagonals bisect each other. First of all, it's a quadrilateral if it has 4 sides. But it's only a parallelogram if the opposite sides are congruent and parallel. But it's also a parallelogram if the diagonals of this quadrilateral bisect each other. So in order to show that they bisect each other, we're going to have to show that their midpoint is the same. So I'm going to draw a really quick sketch just because it helps out. So one of our points is at 1, 2. Here's P. Q is at 4, 4. Here's Q. R is at 5, 9. So here's R. And S is at 2, 7, which is going to be, yeah, it wasn't very good. Let's try that again. Maybe more like here. All right, there's my four-sided figure. And we want to show that these diagonals bisect each other. So those two must be congruent, these two must be congruent, or in other words, their midpoints must be at the same location. Okay, so we want to find the midpoint from P to R. So our midpoint from P to R is going to be the sum of the x values divided by 2 and the sum of the y values divided by 2. In other words, it's the average. So 6 over 2, 11 over 2, so we find out that it's at 3, 5.5. Now let's find the midpoint. And I should make that capital. Oops. Capital M as opposed to little m. QS is at the exact same location. So is 4 plus 2 over 2, comma, 4 plus 7 over 2 at the same location? Well, look at what we get. 6 over 2, 11 over 2, which gives us 3, comma, 5.5. A theorem from elementary geometry states that the quadrilateral is therefore a parallelogram, since their midpoints are at the same location. In geometry, we spent quite a bit of time talking about circles. Now we're going to talk about circles on the coordinate plane. The equation of a circle comes from the distance formula, which is why it kind of looks similar to the distance formula. So the circle whose center is actually at the origin is the equation x squared plus y squared equals r squared, where r is the radius and the center is at 0, 0. But we can put circles wherever we want. So if we want to change where the center is, we're going to call the center h, comma, k. And the equation of the circle therefore becomes x minus h squared plus y minus k squared equals r squared, where r is still the radius. Now, remember h, comma, k as the variables that we use for the center of a conic section, because that's going to come back to haunt us in the next section as well. All right, so let's figure out how to graph a circle on the coordinate plane. So let's start with x squared plus y squared equals 25. Now, because the equation is x squared plus y squared equals r squared, the radius must be 5. The center in this case is at 0, 0. The easiest way to do this is start here at 0, 0. And if the radius is 5, and already I have a circle or congruent, then the easiest way to draw this is to go 1, 2, 3, 4, 5 units to the right, 2, 3, 4, 5 units to the left, 1, 2, 3, 4, 5 units above, and 1, 2, 3, 4, 5 units below the center, and then you can draw your circle. And I drew a not too shabby looking circle. All right, let's go back now and look at the second equation. I'll do that in a different color. Let's do that in blue. X minus 2 squared plus y minus 1 squared equals 25. The radius is also 5, but this time the center is at the location 2, 1. So we're going to start here at 2, 1 and do the exact same thing I did in the last example, which is I'm going to go 1, 2, 3, 4, 5 units to the right, 1, 2, 3, 4, 5 units to the left, 1, 2, 3, 4, 5 units above, and 1, 2, 3, 4, 5 units below. And then here's my circle. Now, instead of drawing a circle, let's find an equation of a circle. Let's start with a simple one. Find an equation of a circle with radius 3 and center 2, -5. Well, the reason this is easy is because as long as you know the equation of a circle, which is x minus h squared plus y minus k squared equals r squared, I know that this, must be h, this must be k, and this must be r. So when I go plug it into the equation, I get x minus h is 2 squared plus y, I'm going to run into this, y minus negative 5. Two negatives make a positive. And then r squared, so 3 squared is 9. Or you can write it as 3 squared if you want to do that as well. All right, let's make this a little more complex. Let's instead find the equation of a circle that has points P at 1, 8 and Q at 5, negative 6 as the endpoints of a diameter. Now, remember in a circle, the diameter is that line that goes smack dab through the middle of the circle, which means that half of the diameter is the radius. So I could do one of two things. I could find, well, I need to do two things. Let's do it this way. I need to find out where the center of this circle is. And it turns out that the center is at the midpoint of the 2 points on the diameter. So let's find the midpoint of PQ, and then I'll know where the center is. So the midpoint is at 1 plus 5 over 2, comma 8 plus negative 6 over 2. So that's 6 over 2, comma 2 over 2, which means that the center must be at 3, comma 1. So I know what H and K are. Okay, now I can do one of two things. In order to find out what the radius is, I could find the diameter, the distance between the 2 points on the diameter, and divide that by 2. Or now, because I know where the center of the circle is, I could find the distance from the center to one of the endpoints, which would give me the radius. And it really doesn't matter which one you do. There is a third way of doing it. You could just take the two ordered pairs that lie on the circle, or sorry, not the two ordered pairs. You could take the center and the one of the points on the outside of the circle and plug it into the circle formula to find the radius, because really that's just the distance formula anyway. So whichever way makes the most sense to you, that's how you should do it. I'll show you how the textbook does it, and it's a fine method. They remind us that the equation of the circle is this. So they go, okay, I'm going to pick the center, and I'm going to pick one of the outside points. How about we pick P at 1, 8, because neither of them are negative. Well, that's going to be my X and Y. So how about I do 1 minus 3 squared plus 8 minus 1 squared is equal to r squared, because I need to know what r squared is to write the final equation of the circle anyway. So I get negative 2 squared plus 7 squared is equal to r squared, so I get 4 plus 49 is r squared, so r squared must be 53. So the equation of the circle must be x minus 3 squared, because remember when we write the final equation of the circle we only use h, k, and r, y minus 1 squared equals 53. What would happen if I were to take the standard equation of a circle and actually square those binomials and then combine like terms? I would get this thing called the general equation of a circle, which is x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are just coefficients that I don't know yet. One of the things I want you to notice about the general equation of a circle is that the coefficient in front of both x squared and y squared is 1. That's how we're going to know this is a circle, because when we talk about our other conics in the following sections, those coefficients in front of x squared and y squared will not necessarily be 1. Alright, the last thing that we want to cover in the coordinate geometry section, even though there's more information, we're really focusing just on the circles right now, We want to show that the equation x squared plus y squared plus 2x, minus 6y plus 7 equals 0 represents a circle, and find the center and radius. Well, it would be helpful to find the center and radius, or if I wanted to graph this, if this equation were in that standard form, that x minus h squared plus y minus k squared equals r squared. And right now it's not. So in order to put it in that form, we're going to go back to a process that we kind of talked about in Algebra 2 called completing the square. If you were in the honors class, you did completing the square. If you were in the regular class, you may or may not have seen it. So this may be new to you. This is how it works. I'm going to group the terms that have x's together in a set of parentheses with a blank. Because what I'm going to do is I'm going to complete that trinomial with a number, and we'll talk about what that number is in a moment. And then I'm going to put another plus sign, and now I'm going to group the y's together in their own parentheses with a blank. The constant 7, I'm going to move that to the other side of the equation. So when I do that, it becomes negative 7. Now, there's this rule about equations that says you can add and subtract whatever you want as long as you do it to both sides of the equation. So if I'm going to add two new numbers to the left-hand side of the equation, I'm going to also add the same two numbers to the right-hand side. Otherwise, that equation's not balanced. All right, now let's talk about what goes in that blank. Well, we're going to do something called completing the square. We're going to create a perfect square trinomial. A perfect square trinomial was one where the last term was a perfect square, like 1, 4, 9, 16, 25, 36, 49, 81, 60, I forgot 64, 100, 121, 144, numbers like that, a number times itself. The middle term of the trinomial is that same number plus itself. So what you can do to find the last term is take the coefficient on the middle term, divide it by 2, and then square it. Well, for the first parentheses, 2 divided by 2 is 1. 1 squared is 1. Take the middle term divided by 2 and then square it. And that'll give you this number. Now I want you to think about it. Is 1 a perfect square? Well, yeah, it's 1 times 1. The middle term must be 1 plus 1 in order for it to be a perfect square trinomial. Well, 1 plus 1 is 2, so it must have worked. It doesn't matter right now if the middle coefficient is positive or negative. So I'm just going to worry about the fact that in the y parentheses, there's a 6 on the middle term. I'm going to take 6 divided by 2 and square it. So 3 squared is 9. Is 9 a perfect square? Well, it is. It's 3 times 3. The middle term must be 3 plus 3, which it is because it's 6. Those same two numbers go on the other side of the parentheses. Okay, now, the next thing we're going to do is we're going to factor those perfect square trinomials. Well, if you think about it, when you factor a trinomial, you always ask yourself what two numbers multiply to give you the last number but add to give you the middle. Well, in this case, they're both 1. Well, remember when you multiply something by itself, it's the same thing as being squared. So perfect square trinomials are really easy to factor. In the y parentheses, the two numbers that multiply to give you 9 are 3, and then because you need the two numbers to add to negative 6, so when you factor this, you get y minus 3, which ends up being y minus 3 squared. So x plus 1 squared plus y minus 3 squared is equal to negative 7 plus 1 plus 9 is 3. There's the equation of the circle. Now that you know the equation of the circle, you can tell me what the center is. The center is at negative 1 comma 3. Remember, the original formula was x minus h squared plus y minus k squared equals r squared. Because people often forget that if the parentheses has a plus sign on it, in it, then h must have been negative because it changed the sign. The radius is the square root of 3. You don't even have to turn it into a decimal. Just leave it as the square root of 3. And that covers the coordinate geometry section 1.8 and what you need to know about circles, distance, midpoint, slope. We didn't really cover slope, but it'll come back to haunt us in a few.